Imagine this. You are walking along. Suddenly the floor gives way. You stumble. You are falling. Below you isn't water. It isn't even a pile of soft cushions. No, you are about to plunge into a vast, shimmering pool. A pool filled entirely with liquid mercury. This is not your typical Tuesday afternoon. Your mind races. What will it feel like? Will you sink like a stone, or will you float? Mercury. You remember it from science class. It's that silvery stuff in old thermometers. The stuff your teacher warned you never to touch. And now you are about to be fully submerged in it. This is going to be an experience. An experience you probably won't want to repeat. But here we go. Splash. The initial moment of impact is probably quite a shock. Not just because you've fallen, but because mercury is not like water. Not at all. It's a metal. A liquid metal, yes, but a metal nonetheless. Think about how heavy a small vial of mercury is. Now imagine an entire pool of it. So, what exactly is this stuff you've just landed in? Mercury. Its chemical symbol is Hg. That comes from hydrargyrum, a Greek word meaning water silver. Which is a pretty good description. It looks like liquid silver. It flows like water, sort of, but it's much, much heavier. It's one of only a few metallic elements that are liquid at room temperature. Mercury is dense. Really, really dense. It's about 13.5 times denser than water. Think about that. A gallon of water weighs about 8.3 pounds. A gallon of mercury would weigh over 112 pounds. Imagine trying to lift that, or swim in it. This density is key to understanding what happens next in our little adventure. It's also what makes mercury so useful in things like barometers and thermometers, and historically in some rather questionable medical treatments. People used to drink it. Don't do that. Another quirky thing about mercury is its surface tension. It's very high. This means mercury really likes to stick to itself. It forms rounded beads. It doesn't wet surfaces the way water does. If you spill water, it spreads out. Mercury, on the other hand, tends to scatter into tiny shimmering balls. You've hit the mercury. What happens now? Do you sink to the bottom like a dropped penny? Or do you bob around like a cork? The answer lies in that density we talked about. Because mercury is so incredibly dense, you are incredibly buoyant in it. Far more buoyant than you are in water. You would not sink, not even close. In fact, you would float very, very high in the mercury. Think of it like this. An object floats if it is less dense than the liquid it's in. Humans are mostly water, and water is much, much less dense than mercury. So, you float. You would probably find that only a small fraction of your body actually submerges in the mercury. Maybe up to your ankles or shins if you were standing upright. If you fell and spread-eagled, you'd be lying almost on top of it. It would be like trying to push a beach ball underwater, but even more difficult. The mercury pushes back. Let's talk about the feel of it. Mercury, at room temperature, would feel cool to the touch. Not icy cold unless the room itself is freezing. But it has a high thermal conductivity. This means it's good at sucking heat away from your body. So any part of you in contact with the mercury would feel a distinct coolness. A metallic chill. It's not the refreshing cool of water on a hot day. It's a more alien penetrating cold. Then there's the texture, or lack thereof. Mercury has very low viscosity when it's not contaminated. It flows easily. But because of its high surface tension, it doesn't wet your skin in the same way water does. Water clings, it makes you feel wet. Mercury would feel more like your skin is being pushed by a very smooth, very heavy, slippery substance. It might beat up on your skin and clothes. Little silver droplets rolling around. It would feel incredibly strange. Unnatural even. Imagine trying to move through it. Section 5, don't breathe deep, the danger in the air. So you're floating awkwardly, feeling chilled, and a bit like you're in a science fiction movie. But the biggest immediate danger isn't necessarily the liquid mercury you're touching. It's the mercury vapor you're breathing. Mercury is volatile. That means it evaporates, it turns into a gas. Even at room temperature, a pool of mercury will be giving off invisible, odorless fumes. And these fumes are incredibly toxic. Every breath you take near that pool is drawing mercury vapor into your lungs. From your lungs, it gets absorbed into your bloodstream. And from there, it travels all over your body, including your brain. This is where things get really nasty. Acute exposure to high levels of mercury vapor can cause severe lung damage. Think chemical pneumonitis. That means inflammation of your lungs. It can make breathing difficult, painful. You might start coughing. You might feel a tightness in your chest. The symptoms of acute mercury vapor poisoning can come on quickly. Besides lung problems, you might experience tremors, muscle weakness. Section 6. Mercury's mean streak, how it harms your health. Let's say you get out of the pool. You're toweling off the silvery beads. Don't do that, by the way. Bad idea. The danger isn't over, not by a long shot. Mercury is a cumulative toxin. That means it builds up in your body over time. Even small exposures, repeated often, can lead to chronic poisoning. And the effects of mercury poisoning are widespread and devastating. It's particularly fond of your nervous system. Your brain and nerves are prime targets. Once mercury gets into your system, it can interfere with all sorts of cellular processes. It loves to bind to proteins. This can mess up enzymes, which are vital for countless bodily functions. In the brain, it can damage neurons. This can lead to a delightful array of neurological problems: memory loss, difficulty concentrating, mood swings, irritability, depression, anxiety. The Mad Hatter from Alice in Wonderland? His madness was likely inspired by mercury poisoning. Hat makers in the 18th and 19th centuries used mercury to process felt, and many went well mad. But mercury doesn't just stop at your brain. Oh no, it's an equal opportunity destroyer. It can damage your kidneys, your liver, your immune system, your digestive system. Symptoms can include tremors, often called Hatter's shakes or mercury tremors. Section 7. The Earth's unwanted souvenir: Mercury's lasting mess. So, you've had your unfortunate dip. You're dealing with the personal health fallout. But what about the pool itself, and the environment around it? A large mercury spill, like an entire pool of it, is an environmental disaster. Mercury doesn't just disappear, it doesn't break down into harmless substances. It persists in the environment for a very, very long time. It's the gift that keeps on giving. In a bad way. If that pool of mercury were to leak into the soil or water systems, it would cause widespread contamination. In water, microorganisms can convert elemental mercury into methylmercury. This is an even more toxic organic form of mercury. Methylmercury is easily absorbed by aquatic organisms. Small fish eat contaminated plankton, bigger fish eat the small fish, and so on up the food chain. This process is called biomagnification. By the time you get to large predatory fish or birds and mammals that eat fish, the concentration of methylmercury can be very high. This contamination can render fish unsafe to eat for decades. Section 8. Cleaning up quicksilver, a truly sticky situation. Okay, so we have a pool of mercury. It's dangerous, it's bad for the environment. How do you clean it up? Very, very carefully. And with great difficulty. Cleaning up a mercury spill is not like mopping up water. Remember those little beads it forms? They roll everywhere. They get into tiny cracks, under floorboards, into porous materials. It's a meticulous, painstaking process. For a large spill, like our hypothetical pool, you'd need specialized teams. Hazmat suits are a must. Respirators too, to protect against that nasty vapor. The first step is often to try and collect the visible liquid mercury. This might involve using special mercury vacuums. These vacuums have filters to trap the mercury and prevent vapor from escaping. Or you might use pumps designed for heavy liquids. But you can never get all of it this way. Those tiny droplets are too sneaky. After removing the bulk liquid, the real detective work begins. You need to find all those hidden beads. Section 9. The allure of the alien. Why mercury still captivates. So, falling into a pool of mercury? A terrible idea, highly dangerous, potentially lethal. Bad for you, bad for the planet, a nightmare to clean up. And yet, there's something undeniably fascinating about mercury, isn't there? This liquid metal, this quicksilver. It behaves so differently from anything else we commonly encounter. It's like a little piece of alien material, right here on Earth. Its shimmer, its weight, its strange properties, they capture the imagination. Throughout history, mercury has held a certain mystique. Alchemists were obsessed with it. They believed it was a primary component of all metals. They thought it could be used to transmute base metals into gold, or to create the elixir of life.